Welcome back, students. In the last class, we have discussed uh, Clairaut's form or example converted into Clairaut's form and find its general and singular solution. That example already covered in the previous videos. I will use the description. I will use the link in the description box, and you can go through that. That is, I have already discussed what is the procedure. What is the definition of Clairaut's equation and how to find what is the procedure to find out Clairaut's equation, and I have solved two examples on Clairaut's equation. Now this example is totally based on linear differential equation with constant coefficients. Okay, so d square y by dx square, it's a second order linear differential equation, and it is non-homogeneous because right side is not equal to 0. So now how to find out solution? So first, to find the solution of this equation, we need to express in a standard form. What is standard form? F of d into y is equal to phi of x. So left side is a function of d into phi of x. Function of d into y is equal to phi of x form. Okay. So as you know this already, you can use d by dx is equal to capital D and d square by dx square is equal to capital D square in the above equation. So it will converted into d square y minus 6 dy plus 10y is equal to cos 2x plus e raised to minus 3x. Here you can take y common in the right side. Okay. Is equal to cos 2x plus e raised to minus 3x. Now it is in the standard form. Now if it is a standard form, now we are writing auxiliary equation, student. Auxiliary equation. What is the auxiliary equation of this equation is replace d by m, that is m square minus 6m plus 10, and neglect right side, means you have to take it as a 0. And remember, the solution of non-homogeneous linear differential equation contains sum of complementary function and particular integral. First we are finding the complementary function here. Now how to solve this equation? Now we are using Sridhar's formula. Okay, a is equal to 1, b is equal to minus 6 and c is equal to 10. Sridhar's formula, as you know already, quadratic equation in terms of m. So that is m is equal to minus b plus or minus square root of b square minus 4ac divided by 2a minus b minus plus 6 plus or minus square root of b square 36 minus 4, a is 1, c is 1, 4 into 10, 40 divided by 2 into a is 2, 6 plus or minus 36 minus 40 minus 4 divided by 2, 6 plus or minus square root of minus 4 is 2i. It's a imaginary, divided by 2. Take 2 common in the numerator. 3 plus or minus I divided by 2. 2 to get cancelled. You will get 3 plus or minus I is the root. So with respect to this, what is the complementary function? So complementary function CF is denoted by YC, since the roots are imaginary. Okay, so we are writing the solution as e raised to, this is 3 times of x into c1 cos I, means we are writing x plus c2 sin x. Okay. Fine. Now this is the complementary function. Now we are going to find out a particular solution, that is yp. Yp is, to find out yp, look at this. You write y as a yp and cross multiply this. So you will get cos 2x plus e raised to minus 3x divided by d square minus 6d plus 10. Okay. So now you can, because this is cos 2x by function of d plus exponential by function of d. Here you have two types of examples. I am writing separately first. Cos 2x divided by d square minus 6d plus 10 plus e raised to minus 3x divided by d square minus 6d plus 10. As I mentioned already, this is type 2 example. This is type 1 example. You call it as, this is P2, this is P1. Particular integral 1, particular integral 2, and call it as equation number some 1. Now let us find out P1 and P2 here. Okay. Fine. Look at how to find out P1, student, where P1 is equal to e raised to minus 3x divided by d square minus 6d plus 10. This is a type 1 example already mentioned. In type 1 example, if e raised to ax by function of d, so to get the particular solution, we are going to replace the function of d by a, that is f of a. We are going to replace d by a. What is the value of a? A is minus 3. Okay. So what you are going to do here? Replace d by a. A is equal to minus 3 to get the particular solution. So where P1 is equal to e raised to minus 3x divided by d by minus 3. 6 into minus 3 plus 10. So this is e raised to minus 3x divided by 9. Okay. 9 minus minus plus 6 3s are 18 plus 10. 18, 28, 30, 37. So e raised to minus 3x divided by 37 is the particular solution of P1. Similarly, let me go for type 2, where P2 is equal to cos 2x divided by d square minus 6d plus 10. In type 2 example, if numerator is trigonometry cos ax divided by function of d, so what we are doing is we are going to replace. First we need to express the denominator as a function of d square, and we are going to replace d square by minus a square. Okay. So we are going to replace by d square by what? Minus a square. Okay. Fine. Now here also, what is the value of a here? A is 2. So replace d square by minus a square minus a value is 2 square, which is minus 4. Okay, replace it and observe what will happen. Cos 2x divided by minus 4 minus 6d plus 10. So this is cos 2x divided by minus 6d minus 10 minus 4 plus 6. Okay, 10 minus 4 is 6. Okay, you can take common 1 by 6 is common in the denominator. What is left here? Cos 2x divided by minus d plus 1. So again d appears in the denominator. What do we need to do? We are going to rationalize here, which is minus d minus 1 minus d minus 1. So on rationalization, On rationalization, so what will get? On rationalization, okay, once again we get, keep it 1 by 6 outside here, okay. So minus d times of cos 2x. So minus d times of cos 2x. Differentiation of cos 2x is minus plus 2 sin 2x. Cos 2x is minus sin 2x, into x is 2. So minus 1 into cos 2x divided by, this is a plus b into a minus b, a square minus b square, that is minus d whole square minus 1 square, or 1 by 6 times of 2 sin 2x minus cos 2x divided by d square minus 1. Again it is type 2 example, okay. So replace again d square by minus a square, that is minus 4. So 1 by 6 times of 2 sin 2x minus cos 2x divided by minus 4 minus 1. So minus 4 minus 1, how much? Minus 5. Minus 5 into 6, minus 30. So minus 1 by 30 times of 2 sin 2x minus cos 2x. So we have find the complementary function for the right side, okay, that is cos 2x as well as e raised to minus 3x. Therefore yp is equal to, that is equation number 1 becomes, so this is first one is minus 1 by 30 p2 into 2 sin 2x minus cos 2x. p1 is plus e raised to minus 3x divided by 37. So finally general solution is sum of complementary function and particular integral. Therefore general solution is y is equal to yc plus yp. What is yc? So yc is e raised to 3x into c1 cos x plus c2 sin x plus yp. Yp is minus 1 by 30 times of 2 sin 2x minus cos 2x plus e raised to minus 3x divided by 37. Thank you so much for watching. Okay. In the next video, we'll have more examples. Okay, thank you.